Hello again. This is Muhammad. Uh, we're going to talk about descriptive statistics today. We'll try to cover most of the basic concepts in descriptive statistics in this session. These are the objectives of today's session. So after this session, I expect you to know what the measures of central tendency are, which one to use, when to use them, and how to perform them in Jamovi. I also expect you to know what the measures of variability are, uh, which measure you should use, when you should use each of them, and how to calculate each of them in Jamovi. If you haven't downloaded the data so far for this module, please go to the link provided in this slide and download the data. Uh, we will use this data set for doing some descriptive statistics during this session. The name of this data set is PWA naming. PWA is an abbreviation I will use during this module. It stands for people with aphasia. So this data set is just made for the purpose of this module, is not real. And then once we start analyzing, we might see some patterns, some relations. That doesn't mean that you could see the same relations and patterns out there in your own situation or in the clinic or context you're working. So in this data set, there are 30 people with aphasia. Um, we have different types of data about them. Uh, the dependent variable here is the picture naming latency. Like we showed them a couple of object pictures and we asked them to name those pictures, and then we recorded their reaction time in millisecond. And then there are other types of variables here too, such as gender, such as treatment type, such as aphasia type. We measured their level of anxiety 3 times during the course of um, treatment, once before the treatment, once right after the treatment, and then uh, once again 6 months after the treatment was over, which we call it delayed anxiety measurement. And then we also uh, collected uh, comprehension, production, and pragmatic uh, measurements. Uh, like we gave them tests of comprehension, production, and pragmatic, and then at the end of the day, we had some scores. And also we have information about their education level. So this is more or less the type of data set we're gonna play with during this module. So I want you to download it if you haven't and have a look at them and see like what the different variables are before we uh, start doing the descriptive statistics. Well, we start first talking about measures of central tendency. Imagine you have collected your data and like the same type of data we have right now. You have people with aphasia, name some object pictures, and then you record the reaction time. So the very first question people ask you is, what is the mean of the response time? Like, how long does it take for the population, for the sample on average to name an object? That is called mean or average. So you kind of, that's the formula here. You kind of sum up all the numbers and then you divide by the number of participants, and then you get the mean, which is a very popular measure of central tendency, where you can see that uh, if you are writing a report or you're even reading a report, you'll see this measure almost always reported. But this is not the only measure. We have two other measures, median and mode, two other measures of central tendency. Median is the once you sort out the numbers from the smallest to the largest, is the middle number, is the number in in the middle which divides the lower portion of the data from the upper portion of the data. So basically it's a line which divides your data into two parts, lower and higher. So you might ask then, if we have mean, why we need to use median? I'll talk about it later, why we have these three types of measures of central tendency and which ones we can use. And the last measure of central tendency is mode. Mode is very simple to define, is the most frequent observation in your data, is the thing which has occurred the most in your data. And it's also like very, very useful when it comes to categorical data, specifically categorical data. For example, you have like different uh, types of people uh, in your sample or in your study who have aphasia, and then you just want to say which, like, fluent or disfluent, and you want to report which one of them participated the more in your study. Basically, you can present mode, which is more like a frequency table. All right, now with these three types of measures of central tendency, now the question is, uh, when should you use each of them? Well, of there's a table here which, I mean, it which kind of summarizes the whole thing I'm going to talk about, but there are 2 points. uh, you kind of make decision based on these 2 points. So one is the type of the data you have, the measurement, the scale of the data you have, and whether you have any extreme values or outliers in your data. If the type of the data you have is nominal data, you definitely need to use mode to present the central tendency of your data, and mode is not at all influenced by outliers. So once you have nominal data like sex, like type of aphasia, and like degree, these are categorical variables or nominal variables, so you need to use mode. On the other hand, then it comes to median and mean, and then you might think that when you want to use them, median could be used with ordinal or interval data. The good thing about median is that it's not at all influenced by outliers. Mean is used when you have interval data. However, one disadvantage uh, with mean is that it's highly influenced by outliers and extreme values. So uh, most of the times, if most of the times we're working with interval data, so people expect you to present mean in your report, but if you also have outliers in your data, try to present media as well. I mean, it's not going to do any harms if you present mean and median, both of them together. It just gives a more clear insight into your data. Now we want to see how we could calculate these measures of central tendency in Jamovi. So I opened my data here. This is the same data I've shared with you. So I changed the levels of measurement and everything, and I saved the latest edition, and I'm just using the latest edition. So, picture naming latency is here. This is the variable I want to calculate the mean and median of this variable. Uh, Picture naming latency is the reaction time measured when people with aphasia were naming some objects. So it's an interval scale variable. And then if you remember from the previous slide, if our data, if our variable is on a is on an interval scale, then we could think about calculating mean or median. So we go to analysis, click on exploration, and then you'll see descriptives here. Click on descriptives. You see a window here where we have a list of variables. These are the same variables in our data. And then we have a box here on the right, which is for the results of descriptive statistics. It seems that is empty because we haven't yet put any of the variables into this box. Once we put a variable into this box, we'll see numbers showing up here. So we're interested in picture naming latency. We want to calculate mean and median for this variable. So once you put that into that box, I mean, the numbers come out here. So you'll see N stands for the number of people in this data set, which is 30 people. We have no missing data because it's 0. And the uh, average time it took for the participants to respond or to name an object, a picture of an object, it was 1450 milliseconds. And the median is also very close to that value. We don't need the other values yet, but I'll talk about them later on. So if uh, you have an interval variable and then you want to calculate the mean and median, that's how you will do that. You go to the exploration descriptive and then you put the variable here in the variables box, and then in the results box here, you'll see the outcome. And then basically you can report this number or this number in your project. But then now, okay, we'll put that out, and then let's go to fascia type. Okay, fascia type is a categorical variable, is a nominal variable. So if we put it in the box, there is nothing here for this variable. It really makes sense because I told you that mean and median are for interval data, and fascia type is a nominal variable. So if you want to calculate the uh, mode, you basically click on frequency table, and then there comes a frequency table here. You can see that out of 3 people, we have 15 people who have fluent aphasia, and we have the other half, 15 other people who are classified as non-fluent. So if you want to talk about the mode, you can basically uh, present your data like this. Um, I think that's all for this. That's how you calculate mean, median, and mode here. And yeah. While measures of central tendency talk about a single value, a typical value in the database, measures of variability are about distribution of the values in your data set. They're about the dispersion. So the question we ask when we think about measures of variability is that how distributed our data points are. And then we have three types of measures: range, variance, and a standard deviation. I'll talk about each of them, and then uh, we'll see how we can calculate them in Jamovi. But before we move on to definition of each of these terms, I'd like to talk about why they're important. What is it that makes them very important? Let's just start with a hypothetical example. Imagine uh, you have two groups, I mean, who go through two different types of treatments. These are people with aphasia. You design two different types of treatments, and then you randomly assign them to each of the treatment groups, and you give them a treatment for several months, and then you kind of give them some tests like a comprehension test, production test, and then you measure their comprehension or production abilities. And then you see that in both of them, you see that their mean is like 100 out of like 150. The mean of each group is 100. So if you only want to decide based on mean, which is a central tendency measure, you might think that, all right, I mean, your treatments work equally well for both of the groups because they have the same mean. But that's not true. That's just one side of the coin, one side of the story. Uh, What makes variability and what makes measures of variability very cool is that they give you a different insight on your data. So if you look at this graph here, you'll see that the mean is 100 in both of them. However, the variability is highly different in these two groups. The graph on the left, it seems that the data is highly clustered and there is not too much dispersion or variability in the data set. However, the one on the right, you can easily see that although the mean is 100, the data is highly disturbed. So it's highly distributed and we have a lot of dispersion in the data. By dispersion, I mean like uh, we have outliers and then numbers in the data set are highly different from each other. Uh, so I hope that you understand through this example why measures of variability are as important as measures of central tendency. So if you have a set of data, you always want to report one or two measure of central tendencies, such as mean or median. And at the same time, people expect you to report at least one measure of variability to show that how uh, spread out your data is. Well, let's start off with range first. Range is the difference between the smallest and the biggest number in the distribution, which, as you can see, is very, very easy to calculate. But one disadvantage of range is that it's very, very sensitive to outliers. So if you have extreme values in your distribution, then range cannot be the best solution to measure variability. In the context of the example I just gave you, where you had two groups going through two different types of treatments, so you could think about range, that the group with the lowest range probably had the lowest variability, their data was more clustered, and there was less distribution in that group. So range is very useful, but the disadvantage is that it's very sensitive to extreme values. Uh, but then statisticians came up with a solution to address this problem. They came up with another concept, which is called interquartile range. And they divided the whole distribution into 4 quarters and then called each of them a quartile. And then in order to address the outlier problem, the extreme values problem, they only focus on the 2 quarters or 2 quartiles in between. So think about the uh, median, and then they start going down and up every 25%, and that's how they come up with 4 quarters. And then they only focus on the 2 quartiles or quarters in between. In that way, the outliers are not included uh, in the calculation of the range, which makes interquartile range very robust against outlier. If you remember when we were talking about measures of central tendency, we said that median was very robust against outliers, and uh, while mean was not very robust and was very sensitive to extreme values, here interquartile range is very robust against outliers, which makes it a very uh, suitable uh, variability measure to report if your data has extreme values, if your data is not normally distributed, or if your data is skewed. You definitely need to think about reporting interquartile range too. Okay, the second measure of variability is called variance. Unlike range, which was sensitive to the 2 extreme values in the sample, or in other words, range was calculated based on the lowest and largest value in the sample. Unlike range, variance is sensitive to all the values in the sample. I'm going to show you how we could uh, calculate variance, but that doesn't mean that you need to calculate variance by hand. Uh, Jamovi will do it for you. Very simple. But anyway, it's good to know how it's calculated. So I put the formula or equation for a variance here. Uh, so you kind of have every raw number, which is x, and then you have the mean with the x bar, and then you basically subtract the mean from every single value in your sample, and then you square it, and then you sum all the squared differences, and you divide it by n minus 1. That's how you get the variance. That's why I said that variance is calculated based on every individual score or value in your sample, unlike range. And then you could see in the table here, you could see every step. So if you want to do that on a sample data set by your hand, you can do that. So variance is very useful. I mean, in the context of the example I just gave you, like having 2 groups going through 2 different treatment strategies, the group with the lowest variance or lower variance is the group where uh, the data is not very much distributed, is the data is very clustered. So that means that compared with the group where the variance is higher and the data is more spread out, uh, the group with the lower variance has been responding to the treatment more similarly. So it really depends how to interpret it in the context of your study. It's not doesn't mean that the lower variance the better, but in the context of the example I gave you, the lower variance means that the treatment was working better uh, because the participants, people with aphasia, were responding to the treatment more similarly. In contrast with the treatment or the group where uh, you have a lot of dispersion in your data and the participants were not reacting to the treatment very similarly. However, one disadvantage of variance is that the variance is in square units. So you kind of square everything, and then the value you get is not in the regional data unit. In order to address this problem, statisticians came up with another measure of variability, which is called standard deviation. Standard deviation is just a square root of the variance. So you basically follow the same procedures uh, to calculate variance, and you have just a final stage where you square root a the outcome of variance. And the advantage of a standard deviation over variance is that the square root, when you square root a variance, it returns the value to the natural units. So you can, it's easier to interpret that because it's in the same unit as your data is. Again, in the context of the example I gave you where you had two groups, two different treatments. Uh, for example, the mean was 100 for both of the groups, but the standard deviation for one group was like 20, but for the other group was 40. So definitely the group with the lower standard deviation, which is 20, was responding more similarly uh, towards the treatment. So what does it mean to have a standard deviation of 20? Standard deviation of 20 means that once the mean is 100, it means that uh, typically speaking, a, a kind of the most of the people in that group, they had a mean of 80 to 120, unlike the other group where the standard deviation was 40. So if you go -1 and +1 a standard deviation from the mean, in the other group, the typical mean was from 60 to 140. That's a big difference. That's how you kind of see how spread out your data is. But this was a brief interpretation of a standard deviation. Later on, I'm gonna give you more examples and like so that you kind of come to grips with the idea of a standard deviation and how you can use it in your data. Okay, let's see how we could calculate these measures of variability in Jamovi. So you see that I have the same data set here. We've been working with this data set throughout this session. So we'll go to exploration again, descriptives. So we've got the same windows here. So we want to look at the uh, variability in the picture naming latency variable. So we'll put that variable into this box, and then we scroll down a bit, and then we have mean, median selected. So we kind of select these values too, because we also want to show the values for uh, interquartile range. So we have dispersion here. We have a standard deviation, which is already selected. We need to select variance, range, and IQR, which stands for interquartile range. And you could then you go to the window here. You can see that we have 30 participants in this data, number of missing variables, number of missing participants 0. So we have mean, median, and the standard deviation is 213. So that means that the typical mean for this group is minus or plus one standard deviation from the mean. Like it would be around 1, 20, 37, I think, 120, 40 to 1, 60, 1660. Around these values would be the typical mean. And then we have variance, which I told you the variance, you can't really interpret that because it's not in the regional units as the data is, but the standard deviation is in the natural units, so it's easily interpretable. And then we have IQR, interquartile range, which is 255 compared to range, which is 757. There is a big difference. So it means that there are some extreme values, there are some outlier values in this variable because the difference between IQR and range is a big difference. We have the minimum and maximum, so the range is calculated by subtracting the minimum from the maximum, and then we have the quartiles here, uh, the first quartile, the second one, and the third one. So once you subtract this one, the 75th percentile from 25th percentile, you should get IQR, which is 255. So uh, I think that's it. So we talked about mean, median, and mode as measures of central tendency, and then we talked about range, interquartile range, uh, variance, and a standard deviation, and also I demonstrated how we could calculate these values in Jamovi. So basically, the next level will be to report them in your study or in your report. Um, yeah. Now is the time to decide which measure to use if you want to report any of them. Well, uh, I just said that range gives you the fullest spread of the data. Indeed, if you don't have extreme values in your data, it's good to report range. However, this is not the case most of the times, and you can't really control many of those outliers, so they kind of pop out in your studies. So we have other options too. One good option is interquartile range, which is the middle portion or half of the data. Is where you find the median, and then around that median, you kind of find the middle half, and then you report it. It's pretty robust, as I said, against a extreme values, and it's a nice complement to median. If you want to report median, it's also good to report IQR. Then we had variance. I should tell you that variance is almost never reported in research papers or studies uh, because it's squared. It's not in the same unit as the data is, so you can't really interpret that. It's not very easy to interpret that. However, variance is almost always used to calculate uh, the majority of the statistical tests available. Yeah, it's very useful, but I mean, you never report it. So we come to the standard deviation, which is the square root of the variance. Uh, the advantage of standard deviation over variance is that it's expressed in the same units as the data, so it's easy to interpret that. So if you don't have outliers in your data and you're going to report mean as the measure of central tendency, uh, you need to report a standard deviation as well, because a standard deviation, I would say, is the most popular measure of variability. So if you report mean, it's also a default or a standard to report standard deviation as well. Uh, then, uh, uh, so depending on whether you choose median or mean, you choose over IQR or standard deviation, but that doesn't do you a harm if you want to report both of them. So it's good to report both interquartile range and standard deviation in your report or your studies. Okay, with this slide, we come to the end of the first session on descriptive statistics. So uh, now I expect you to know what the measures of central tendency are and how to calculate them in Jamovi. At the same time, I talked about measures of variability, so I expect you to know what measures of variability are and how to obtain them in Jamovi. And most importantly, you need to know how to interpret these measures and where to use each of them. Uh, Next session, I'll talk about skewness and ketosis and what a standard score is and how to use a standard score. So we will have another short session on descriptive statistics, and then we'll move forward. So please let me know if you have any questions. Thank you. Bye bye.